Hello world. In today's video we are going to be looking at finding the direction of the resultant vector, but before we do that we're going to first recap on what we did in the previous video, mechanics number 3. So in that video we looked at calculating the magnitude of the resultant vector. Remember, when we talk about the resultant vector, the key word there is we are looking for a single vector. So if I want to find the resultant vector for these vectors, which are forces, then I need to find a single vector having the same effect as P, Q, and S combined. So the key word is I'm looking for a single vector, and we said to find the magnitude of the resultant vector, first sum the vectors along the y direction and call that ry, find the sum of the vectors along the horizontal direction, call that rx, and then you draw ry and rx and then use the theorem of Pythagoras to find the resultant vector. You can try this one out for yourself. So what I'm going to do is I'm going to go through this example. It does not matter how many vectors you are having. You just always follow the same procedure as described. So step number 1, you need to check which forces or which vectors are collinear. From this diagram over here, we have F3, we have F1, which are collinear vectors along the y direction. And we also have F4, F2. I think I did not label those appropriately. So this one, I am going to call it F5 to avoid confusion. So F2, F4, F5, they are collinear vectors along the x direction. So we are first going to start by finding the resultant along the y direction, which is ry. Before you find ry, remember you need to pick a positive direction, and for this example I'm going to take up as positive for the y direction. So it means the resultant along the y will be equals to positive 50 because it's pointing up, plus I have negative 20, the negative for downwards. The resultant along the y direction will be positive 30 newtons, meaning that the resultant along the y direction has a magnitude of 30 with an upward direction. And when we get to the x direction, along the x direction we are having 3 vectors. So for that direction I am going to take right as positive. Okay, so it means the resultant along the x direction, which is rx, will be positive 15 plus negative 18, which is F4, plus negative 12, which is my F5. So if I sum those together, I'm going to get an answer of negative 15 Newton. So what this means is the resultant along the x direction will be 15 newtons towards the left. Okay, the first 3 steps have been completed. Now we go to the next step where we need to draw these 2 vectors using the tail to head method. So I'm going to start with the one along the vertical direction. I have 30 Newton over here. That is from the tail to the head. When I get to the tail of the 30 to the head of the 30 Newton, I start with the tail of the 15 Newton, and the 15 Newton points towards the left, so that has a magnitude of 15 Newton. And remember how we draw the resultant. The resultant will be a vector which starts from the tail of the first vector drawn to the head of the last vector drawn. Remember the angle between the horizontal and the vertical, that is 90 degrees. So to find r, I'm going to label it r. we are going to use theorem of Pythagoras. Theorem of Pythagoras only helps us with the magnitude of r. So r will be equals to the square root of 15 squared plus 30 squared. So you can punch that on calculator. Just gonna use my calculator right now. We have 30 squared, which is 900. We also have 15 squared, which is 225. 225 plus 900 is 1125. Square root of 1125. The resultant r, the magnitude of the resultant r, will be equals to 33,59 if you round it off to 2 decimal places. And because these vectors were measured in units of newtons, the units for r will also be newtons. But when we go back to the diagram for the resultant, I'm going to draw my y-axis, x-axis. If we look at the resultant r, the resultant r is somewhere there. It is not along the y direction, it's not even along the x direction, but rather r is some angle from the x axis. So it means when we need to determine the direction of the vector r, we need to use an angle to identify the direction. So if we want to know the direction of r, we are going to need to follow the following set of steps. Step number 1, we're going to be doing what we have been doing. So we are just adding to everything we've been doing. Number 1, you're going to identify collinear vectors. When you're done, you're going to find the resultant along the x direction and the resultant along the y direction. You're going to draw the rx and ry using the tail to head method. And on that diagram, you are going to include the resultant vector r. Remember, resultant is from the tail of the first vector drawn to the head of the last vector drawn. Once you are done drawing r, you are going to indicate the direction of r. The direction of r, you can use an angle like theta to indicate it. But when you indicate theta, theta is the angle between r and the x-axis. That it could be the positive x-axis or the negative y-axis. The negative x-axis. So you just use whichever one is closer, and your theta should be an acute angle. And then you're going to use trigonometric ratios to find the angle theta. So if I go back to the diagram which I am having above here, I can include the Cartesian plane on this diagram. Normally you can include the Cartesian plane on the tail of the vector that you draw first. That will be my Cartesian plane. So this means if I draw my Cartesian plane, then theta will be between the x-axis, there are the x-axis, and the vector r. So that will be my theta over there. So to find theta, we are saying we need to make use of trigonometric ratios. So it's up to you how you would like to find your angle theta. You can find this angle here first and use the fact that this angle and theta, they add up to 90 degrees. Or alternatively, what you can do is you can draw a copy of the two forces, Rx and Ry. So I'm going to draw the copies in a different color. I'm going to go for red. So as long as two vectors, they are in the same direction and they have the same magnitude, then they are equal as described in the revision video. Okay, so I'm going to draw a copy. This is a copy in red because it's along the x. This is a copy of our x, and this over here going upward, this is a copy, my apologies, supposed to be vertically up. This is a copy of ry with a magnitude of 30 Newton. Remember the angle between Rx and Ry, that one is 90 degrees. Now, if we look at this diagram from here, we have this portion. We have this side, that side. We also have the hypotenuse. So we can essentially just put our focus on the bottom right angled triangle. So I'm going to draw a copy of that right angled triangle. It looks something like this, where this is the 90-degree angle, this is our x, this is our y, and this is the angle theta. Okay, this was left and then this one was upward. If we look at the right angled triangle, we know what this length is. This is 30 Newton. We know what this is. This is 15 Newton. And the 30 Newton side Ry is opposite to the angle theta. Remember, when we say a side is opposite, we mean it is facing. So this is the side facing the theta. So this means this side will be the opposite side. And this side, Rx, is the side which is next to the angle. When it is, the side is next to the angle, we say it is adjacent to. So this is the adjacent. We know what the opposite side is. We know what the adjacent is. Which trigonometric ratio can we use to find theta? You guessed it right. We can use the tangent of theta. So this will be tan theta is, okay, tan of theta is equals to opposite, which is Ry, divided by adjacent, which is Rx. So I am taking this from a mathematical perspective. The fact that when we find the angle theta, we are looking at the length of the side Ry and the length of the side Rx. Some people are comfortable in taking into account the directions. If you like, you can do that as well. When people take into account the directions, they are just trying to figure out in which quadrant we are going to find theta. But you and I don't need to worry about that right now, because from the sketch that we drew using the tail to head method, we can clearly see that this is quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. So from the sketch, we can clearly see that theta is in quadrant number 2. So some people might include the signs so that they get a sense of where the theta is found. So I'm not going to include the signs here because I know where theta lies. It lies in the second quadrant, and I'm just using a mathematical concept where Ry and Rx are just the lengths of the triangle, whereby the length is just a scalar quantity. So if you want to find the angle theta will be the arctan of Ry. We said Ry was 30 divided by Rx, which was 15. So I'm going to try to find that on a calculator. So therefore it means theta will be equals to, so let us see, we have 30 divided by 15, that will give us an answer of 2, and we're going to take arctan of 2. If we find arctan of 2, we find that the answer there is 63,43 degrees. I'm just going to write the degrees in words. Degrees. And where is theta located? These are the positive x-axis. These are the negative x-axis. So remember, when we measured theta from the x-axis going in that direction. So this means that theta lies above the negative x-axis. So it means that the angle here is 63,43 degrees above the negative x-axis. To report your angle, you can use this method to write down your angle, or you can follow the guide on how the examiner wants the angle. Sometimes you find that they need you to use a bearing to write down the angle. Remember how we were finding our bearings. So let us try to find theta in terms of a bearing. So I'm going to redraw the Cartesian plane. There's our vector r there, and there is theta. Remember, if you want to write down the angle in terms of a bearing, you start from the North Pole as your 0. This will be the 0. We are measuring the angle from there in the clockwise direction all the way to the vector r. How do we find that angle? That will be from there to there 90, plus another 90, which is 180, plus another 90, 270, plus the acute angle, which is 63,43. And remember, I said in the previous video, when you write down the bearing, you write it as a 3-digit number. So that is 270 plus 63,43, and my calculator tells me that in terms of bearing, theta will be equals to 333,43 degrees. So that will be our angle. Okay, and those are basically the steps that we follow when we want the direction of the resultant. Okay. Yeah, feel free to type in any questions that you might have. So with this question, which I skipped earlier, so what I am going to do is I'm just going to draw the resultants and then identify where r is going to be. I'm not necessarily going to solve the whole problem. So for this question, if you try to find the resultant along the y, if you calculate it properly, you will find that the resultant along the y direction will be downward. So that will be your ry. If you try to find the resultant along the x, because there's only one force along the x direction, you'll find that rx will be towards the right. So that will be your rx. And remember that the resultant of the two will be a vector from the tail of the vector that I drew first, which is ry, all the way to the head of rx. So that will be our r. So if I were to draw r on a Cartesian plane, this is my Cartesian plane. My Cartesian plane over there. And that will be the vector r. And the direction of the vector r will be the angle between the x-axis and r. So those are the x-axis, there's r. So that will be the angle theta. And if you like, you can draw the copies of rx and ry. That will be rx over there. Rx, that one will be a copy of ry. the angle there will be 90 degrees. So if you try to report the angle theta at the end, you'll realize that these are the positive x-axis, and this angle theta was measured from the x-axis going downwards. So it means that theta will be some angle in degrees Celsius below the positive x-axis. So when I post the video, I will write down the solution, the answer for the magnitude of r, as well as the size of the angle theta, and I will also write the angle in terms of bearing. Thank you for tuning in, and in the next video we are going to learn how to resolve a two-dimensional vector, and we are going to explain what a two-dimensional vector is. Bye.